The purpose of this program is to provide general information concerning the safety aspects of handling and storing atomized aluminum powder, aluminum flake, and aluminum paste products. Millions of pounds of these products are shipped, stored, and handled safely by thousands of workers around the world year after year without incident. However, under certain spontaneous conditions, aluminum powders, flakes, and pastes can present fire or even explosion hazards. Therefore, it is extremely important that all facilities using these products maintain a scrupulous housekeeping program and strictly follow the safety guidelines discussed in this program. The recommendations presented in this program have been compiled from information provided by the National Fire Protection Association, the American National Standards Institute, and the Aluminum Association, as well as through the industry's own collective experience in handling aluminum powder and paste. Specific and detailed information regarding the safety guidance presented in this program may be found in the Aluminum Association publication, Recommendations for the Safe Storage and Handling of Aluminum Powder and Paste, and the National Fire Protection Association publication, NFPA 484, Standard for Combustible Metals. Since the information provided by this program is by necessity general in nature, viewers are advised to seek expert advice in connection with their individual handling and storage needs of these materials. Material safety data sheets from the supplier will provide detailed information on storage and handling of aluminum powders, as well as information on health aspects of specific products. The Aluminum Association and its member companies make no warranty and assume no responsibility or liability with respect to the suggestions and information presented in this safety training program. Chemically, aluminum has an enormous affinity for oxygen. This results in a thin film of aluminum oxide being formed on the surface of aluminum when it's exposed to air or other oxidizing atmospheres. The aluminum oxide film is inert and protects the underlying metal from further reaction. Finely divided forms of aluminum, such as atomized powders and flakes, present a large surface area for reaction and are prone to rapid oxidation. When an aluminum particle is heated to a sufficiently high temperature, known as the ignition temperature, the mass of the particle is so small that the entire particle may oxidize almost instantly. Thus, a pile of such particles may burn. Since flake particles have a much greater surface area per unit mass than do atomized or granular particles, they will ignite more readily and burn faster than atomized or granular particles. Fine particles of aluminum powder, like many organic powders such as flour, sugar, wood dust, coal dust, and plastic resins, are easily dispersed in air, where their low mass allows them to remain suspended or float in the air for extended periods of time. These suspended particles will burn, similarly to particles in a pile when the ignition temperature is reached. Additionally, when dispersed in the proper proportion in air, the particles are intimately mixed with the oxygen in the air, allowing the burning to extend from one particle to another with such rapidity that a violent explosion can occur. Laboratory tests have established the proportions of aluminum powder required for a dust-air explosion. The concentration of aluminum powder required for an explosion varies through a wide range and depends on the article's size and form. In general, very little aluminum powder is required for an explosion to occur. Tests have shown that aluminum powder in the form of a dust cloud will ignite with as little as 6% oxygen present, with the balance of the atmosphere being nitrogen. Very little energy is required to ignite mixtures of aluminum powder and air. A static electrical discharge will produce a spark that raises the temperature of the aluminum powder articles in its vicinity above the ignition temperature, resulting in an explosion. Conventional electric equipment such as switches, junction boxes, electric motor commutators, broken light bulbs, loose electrical connections, even a metal-to-metal impact, or any spark-producing event can set off an explosion where aluminum powder is suspended in air. Very hot surfaces, such as an engine manifold or continued metal-to-metal rubbing, such as in a dry sleeve bearing, can generate enough heat to initiate an aluminum powder air explosion. A storage area is designated as an area where aluminum powder and paste products are kept in closed, sealed containers separate from production or processing areas. Storage should be in original sealed containers. All containers should be inspected upon receipt and regularly thereafter to ensure that there are no leaks or container failures which may expose the contents to moisture or other contamination. Containers open for removal of product should always be resealed immediately. Storage should be preferably in rooms of fire-resistive, non-combustible, or limited combustible construction. Aluminum powder or paste storage areas should be segregated from those sites where flammable liquids, oxidizers, combustible materials, or other materials that are incompatible with aluminum are stored. Stored containers should be stacked carefully to ensure stability. Ample aisle space should be provided between rows of stored containers to ensure ready access to those containers. Avoid exposure of the stored containers to water. Aluminum powder or paste, when it comes in contact with water, may result in a reaction which could generate significant heating of the powder or paste and also the generation of highly combustible hydrogen gas. Leaks in steam lines, water lines, radiator walls, floors, and roofs should be repaired promptly. Smoking and open flames are prohibited in areas where aluminum powders or pastes are stored. Containers of aluminum paste should be stored in areas where the temperature is maintained below the flash point of the paste solvent. An effective safe handling program focuses on good housekeeping and the control of potential ignition sources. Sources of ignition may include, but are not limited to, cutting torches, welding activities, smoking, grinding, and static electrical discharges. If maintenance activities are planned in an area where aluminum powder or paste are being handled or processed, all machinery, ductwork, and dust collectors must be shut down, emptied, and cleaned, and then all aluminum dust, powder, or paste removed from that area. An effective hot work program should be in place to control potential sources of ignition. Smoking is strictly prohibited in all areas where aluminum powder or paste is stored, handled, or processed. Great care should be taken to avoid the generation of airborne dust during the transfer of aluminum powder and paste products from one container to another. Powder and paste should be transferred from one container to another using non-sparking conductive metal scoops with as little agitation of the materials as possible. Handling must be slow and deliberate to keep dusting to a minimum. All containers must be bonded together and also grounded to minimize the possibility of unexpected static electric discharge. Where aluminum powder and paste are handled or processed, all electrical equipment and wiring must be suitable for areas where Group E conductive dusts are present and installed in accordance with the National Electric Code NFPA 70. All equipment used in the processing of aluminum powder and paste must be thoroughly grounded to eliminate hazardous static discharge. Non-conductive components of processing equipment, for example flexible rubber screen boots, must have an effective bond-to-ground in place. Information on proper bonding and grounding procedures may be found in the National Fire Protection Association's publication NFPA 77, Recommended Practice on Static Electricity. The interior of all processing equipment and ductwork must be inspected regularly for possible accumulations of fine aluminum powder, particularly at change of direction points, such as elbows and other areas where a dead spot may occur. Aluminum powder and paste should not be allowed to accumulate on rusty surfaces. If an impact should occur involving a tool or other object, an extremely hazardous thermite reaction may take place. The use of an inert gas such as nitrogen or argon to replace air, which reduces the level of oxygen to below that which will support combustion, increases the safety of many operations. This is particularly true in cases where it may be impossible to ensure that all sources of ignition have been eliminated. A comprehensive and effective housekeeping program is essential to the safe handling of aluminum powders and pastes. Good housekeeping practices must be maintained in all areas of your facility where aluminum powder and paste are stored and handled. Spills of aluminum powder or paste should be thoroughly cleaned immediately. Excessive accumulations of fugitive aluminum dust create the potential for catastrophic secondary explosions should a fire or explosion take place at the facility. Guard against the accumulation of fugitive aluminum dust on processing equipment, floors, walls, piping, ductwork, and other surfaces. Special attention should be paid to elevated areas, such as exposed building structural members, support beams, and elevated platforms. Areas above suspended ceilings should be inspected regularly to avoid the buildup of fugitive aluminum dust. The interior of ducting used in the transport of aluminum powder or dust should be inspected and cleaned regularly to avoid the buildup of excessive dust on inside surfaces. Cleanup of aluminum powder and dust should be accomplished by the use of soft, natural fiber brushes, brooms, or squeegees with non-sparking conductive scoops or dustpans to pick up the collected material. Care should be taken to avoid excessive airborne dust during cleaning activities. Synthetic fiber bristle brushes, plastic, or other non-conductive scoops should not be used since they tend to accumulate strong static charges. Standard industrial vacuum cleaners must not be used for the cleanup of aluminum powder or paste. Only specialized custom machines specifically approved for use with combustible metal dusts can be used for these housekeeping activities. Since it is almost impossible to extinguish an active dry aluminum powder fire, solutions to the problem are focused on the control of these fires in the incipient stage. Aluminum powder fires are characterized by the emission of extremely bright light, very high heat, and the generation of large amounts of white smoke. Suppressing a metal powder fire should only be attempted by personnel who are trained in the special precautions required for fighting fires involving such combustible metals. In the interest of life safety, an assessment of the situation should be undertaken to determine if the fire can be safely fought with existing resources. It may be that the most prudent course of action would be to isolate the fire as much as possible and allow it to burn itself out. Professional or volunteer firefighters from the surrounding area cannot be expected to be trained for the specific fire and life hazards associated with aluminum powder and paste fires. Local firefighters, however, should be directed by the facility safety personnel for their own safety. Water must never be used to fight an aluminum powder or paste fire, since the water will react with hot aluminum powder to form highly explosive hydrogen gas. The force of the water hose stream may also suspend the aluminum powder and form a potentially explosive dust cloud. Fire extinguishers rated for Class A, B, or C fires also must not be used, since the extinguishing agent may react with the burning aluminum powder and instantaneously accelerate the fire. Halogenated extinguishing agents are also not used on aluminum powder or paste fires. If such extinguishers are present in an area where aluminum powder or paste is handled, they must be marked not for use on aluminum powder fires. Aluminum powder fires on reasonably flat surfaces may be controlled and isolated by blanketing the burning material with a Class D type dry extinguishing agent and then by wringing the burning material with dry sand. Long-handled shovels or scoops made of non-sparking material are to be used for the application of dry extinguishing agents. This should be done with great care to avoid disturbing the powder and forming a dust cloud, as even a minor dust cloud may explode violently. A properly blanketed fire will develop a hard crust of metal oxide, which ultimately eliminates enough oxygen to cause the fire to self-extinguish. After dispensing the extinguishing material, all personnel should leave the area, closing all doors which lead to the area, and then sealing them with sand or other dry granular non-combustible material. All fans and machinery, including dust collection systems, should be completely shut down. Drafts should be eliminated wherever possible. The aluminum powder may continue to burn under the crust without visible flames and therefore should not be disturbed until such time as it can be determined that the fire is completely out. Disturbing the crust may cause reignition of the fire. Flake aluminum powder has a lower density and a much greater surface area than atomized aluminum powder. Therefore, it tends to not only disperse and form dust clouds more easily, but also ignites more readily. Great care must be taken when attempting to extinguish a mass of burning flake powder so that the particles are disturbed as little as possible. Aluminum paste products consist of aluminum flake powders suspended in a high flash point combustible solvent. An aluminum paste fire typically begins as a solvent fire and can be fought using Class B extinguishing agents such as dry chemical, foam, or carbon dioxide. Once the solvent fire is extinguished, the residual powder may reignite due to localized heat or spontaneous heating. To avoid reignition, the residual material should be smothered with a Class D agent. At some point, the paste fire may begin to exhibit the characteristics of a powder fire, at which time it must be treated as such. Obviously, judgment must be used in determining whether Class B agents can be safely used on aluminum paste fires. If the Class B agent is applied carefully, it will be very evident if the fire is accelerated. At this point, the fire is considered to be a powder fire, and the use of Class B extinguishing agent should be discontinued, and a Class D agent, or dry inert granular material such as sand, used in the manner indicated for an aluminum powder fire. Follow the guidelines outlined in the Aluminum Association publication TR2, Recommendations for Storage and Handling of Aluminum Powders and Paste, as well as the NFPA Consensus Standards 484 and 77. As we emphasized at the beginning of this program, aluminum powder, flake, and paste products can be shipped, stored, and used safely, but only if the proven basic rules of safety are carefully followed, and proper attention is maintained to the specific hazards associated with handling aluminum powders and pastes.